Hey folks, welcome to Bonding Review and Ionic Naming. We're going to spend a lot of time on naming this unit. Before we get started, I want to mention that this is the most important unit that you will do all year. You say, well, wait a minute, isn't he going to say that about Unit 9 and Unit 10? And No, I'm not. Okay, this really is. And the reason is when we get into doing reactions, for example, I'm going to give them to you in terms of names, and you're going to have to convert them into substances, into compounds, before you can actually do any work. When you have to balance reactions, you're going to be doing it from names, going to compounds, and then balancing. If you can't convert from names to compounds, you're toast for the rest of the year. So this is the most important unit. So even though the podcasts, with the exception of this first one, are going to be pretty short, there's a lot of worksheets that need to be done, and you need to do them all. And you need to just practice, rote, do it, until it all becomes second nature. Okay? That's the best advice I can give you. All right. Just a reminder of where we came from, the octet rule. The octet rule says that atoms tend to gain, lose, or share electrons in order to obtain a complete valence shell of electrons. And another way to put that is in order to obtain the electron configuration of a noble gas. So what we're going to talk about is the gaining and losing portion, because we're talking about ionic compounds. Valence electrons are the electrons in the highest occupied energy level of an element's atom. So remember, if we have something that's 1s2, 2s2, 2p6, 3s2, 3p1, the only electrons we care about are these guys, because they're at the highest principal energy level. That's what these threes mean. Okay? And usually valence electrons are the only ones that are used in chemical bonds, because they're the ones that are on the outside of the atom. So that's what we're going to focus on. Okay. Remember that ionic bonds are always between two ions, and that metals lose one or more electrons, and nonmetals gain one or more electrons. So we have cations and anions, and opposites attract, and that's what pull these things together. So, for example, we might have a metal like sodium, and it tends to lose an electron, so it gains a positive charge. And chlorine tends to gain an electron, so it becomes negative. So our cation is positive, so that's the Na+, and the ani is negative, so that's the Cl-. And because one is positive and one is negative, these two are going to attract each other, because sodium has completely lost its electron and chlorine has completely gained it. And these things create these crystals that we showed in a previous podcast for ionic bonds. You need to remember that. All right. So for ionic bonds, ionic substances, we can have monatomic, which are one metal and one nonmetal, which are the simple metals, which we're going to do in this podcast. We're going to do transition metals. Those are actually going to be 2 podcasts away, and the polyatomic ones are going to be in the next podcast. So I've actually reversed these 2 right here. All right. So they're going to be in reverse order. Not that you care. Okay, so let's talk about cations. Remember that cations, the ones we care about, are in column 1, the alkali metals, and in column 2, the alkaline earth metals, and we also care about aluminum. And those are the ones we're going to focus on. And remember, everything in column 1 takes on a +1 charge, and everything in column 2 is a 2+ charge, and aluminum is a 3+ charge, right? Because they're losing 1, 2, and 3 electrons respectively. Right, so you should have all that down on a periodic table somewhere. Now, when we're naming them, an ion, a cation, is the same as the name of the element. For example, the sodium ion, which is Na+, is going to have exactly the same name as the metal, which is Na. Right? It does not change. However, the anions are different. Now, we're only caring about these 11 anions over here. Right? Those are the ones we care about. And you'll notice they're way over here on the right-hand side of the periodic table. Remember, we do not include the noble gases because they do not bond. And these take on a -1 charge, a -2 charge, and a -3 charge, respectively. Okay? And they're in groups 5A, 6A, and 7A, or 15, 16, and 17. 17, if you remember, those are the halogens. You need to know that name. Right? So these are the ones that we care about. So an anion is different. The name of an anion is different from the atom, so chlorine becomes chloride. You already knew that. Let's face it. What is this thing right here? All of you know that's sodium chloride. You'd never call it sodium chlorine, would you? No. You call it sodium chloride because you know it ends in IDE. So that's true of all of the anions. So as we go and we look at all of these anions over here, they all end in IDE. So this would be nitride, oxide, fluoride, chloride, sulfide, phosphide, etc. Okay? They all end in IDE. So we should be able to name these pretty easily. Now, this is where, as I said, it's so important to practice these over and over. You should be able to look at these and very quickly come up with the name. Right? For example, you should know that K is potassium, and that's chlorine, so this is going to be potassium chloride. I'm not going to write them down. It's going to take too long. Potassium chloride. So what I'd like you to do, pause the video, see if you can do it. All right, did you have any luck? Did you come up with sodium bromide, magnesium oxide? How about this one? This is cesium sulfide, and I said, well, what about this 2 that's down here? Is that 2 an issue? It tells you have 2 cesium atoms. Is that important? Well, it's important for the compound, but it's not important for naming. So you just call this cesium sulfide and don't worry about the fact that there's a subscript there. Similar down here where you have aluminum and oxygen, you would just call it aluminum oxide. You don't have to worry about the subscripts right now. Okay? So when you're naming something, it's just the metal first and then the nonmetal, and the nonmetal is going to end in IDE because it's on the periodic table. All right, pause the video again, see if you can do these. Okay, you should be able to go and just do this, and these should be getting second nature. We're going to do a lot of these, so you just have to practice them. Cesium fluoride, calcium sulfide, strontium phosphide, barium oxide, barium iodide, and aluminum bromide. Again, the subscripts don't matter when we're going from the compounds to the names. But where do the subscripts come from? Well, the substance must be electrically neutral. So if we think about sodium, for example, sodium has 1 valence electron. And chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons because it's a halogen. So an alkali metal like sodium is going to tend to lose its electron completely. That electron is going to be 100% transferred to chlorine, so it goes away from here and it comes over here to chlorine. So chlorine now has 8 electrons in its valence shell, and actually sodium does as well because it went down 1 level and it now has 10 electrons, 2 in the 1 level and 8 in the 2nd level. So now this guy over here, this guy is completely positive and he's lost 1 electron. And chlorine is completely negative because he has gained 1 electron. Right? So this is now neutral because 1 positive offsets 1 negative. But what about magnesium? Magnesium has 2 electrons. Let's say 1 there and 1 there. And chlorine again has 7. So I'll just draw that quickly. Stop it, stupid pen. All right. So magnesium is going to lose its electron to chlorine, but magnesium still has 1. So the only way to make this thing electrically neutral is for chlorine to go, this chlorine, to take the other electron from magnesium. Right? So magnesium is going to lose both of its electrons, and we're going to have 2 chlorines to gain 1. So this is not going to be MgCl, but it's going to be MgCl with a 2 after it because they're 2 chlorines. Magnesium takes on a 2 plus charge, and each of the chlorines takes on a 1 minus charge, so the 2 plus has to be offset by 2 negative charges to make it equal. Okay? So essentially, you can look at it a different way. Sodium is giving up 1 electron, so we're just going to do that as an arrow, and chlorine is accepting 1. Whereas magnesium is giving up 2 electrons, chlorine only accepts 1, so we need to have 2 chlorines to accept 2. Okay? Draw it however you want. Just make sure you understand it. Right? How about aluminum oxide? Why don't you pause the video and see if you can figure out why that's Al2O3. All right? Well, aluminum has 3 electrons. And we've done this in a video before, but aluminum is losing 3 electrons. Oxygen will accept 2 electrons. If you remember, aluminum has a +3 charge. Right? And oxygen takes on a 2 minus charge. Oxygen will take on 2 electrons, and aluminum wants to lose 3. Well, aluminum has lost 2 electrons to this oxygen, but the problem is it still has 1 to get rid of, so it finds another oxygen. And that oxygen wants 2 electrons, but it can only take 1 from this aluminum. So it has to find another aluminum to go and give it that electron. The problem is aluminum wants to give away 3 electrons, which means we have to find another oxygen to take 2 of them. So you'll notice that aluminum, the 2 aluminums together, have given up a total of 6 electrons, and each of the oxygens is taking 2. So since I have 3 of them, they're taking a total of 6 electrons. So I have a +6 and a -6 charge, and they balance each other out. So that's what's going on. You say there's got to be an easier way. Well, there is. And that's the beauty of this. There is an easy way, right? So let's go and look at a couple of examples, right? If we have, for example, sodium chloride, and I want to use the same ones just so you can see them. That's a +1 and a -1. And because they're 1 and 1, if I take the numbers and I put them down there, I get Na1Cl1. I ignore the negative sign. I just put the numbers down there, and I have 1 sodium and 1 chlorine. Well, because they're 1s, I don't write 1s. So I just get NaCl. What happens if I have Mg and Cl? Well, Mg has a 2+ charge. Chlorine has a 1- charge. When I cross those numbers, the 2 goes after the chlorine. So I have Mg1 Cl2. So the way I would write that, because I don't write the 1s, is MgCl2. How about aluminum and oxygen? Well, aluminum has a 3+ charge, and oxygen has a 2- charge. So when I cross them, I get Al2O3. Much, much easier than doing all the other stuff, but I wanted to make sure you understood why it worked. Okay? And this works. All right? So why don't you pause the video, see if you can do these. All right, so you have potassium iodide, and they both have, this is a +1, and that's a -1. So the 1 and the 1 are going to cancel each other out. I don't write 1, so I just write Ki. See how it works? How about calcium bromide? That is a 2+ charge and a 1- charge. So I'm going to cross the numbers, so it becomes Ca, and it's Br, and there are 2 Brs. All right, if this makes sense, go ahead and pause the video and do the last 2 if you were stuck before. All right, sodium has a 1+ charge, and oxide has a 2- charge because that's oxygen. So this is Na2O. When I cross the numbers, the 2 goes after the sodium. How about aluminum sulfide? 3+, 2-. So this becomes Al2, Al2S3. That's a 2, folks, sorry. Okay? All right. Now be careful. Remember that for sodium chloride, we have a crystal, and it looks like a crystal lattice. You've seen that. But what happens when I get to magnesium oxide? That's a 2+, and that's a 2-. All right? So it looks like it should be Mg2O2. Well, if you remember that one magnesium doesn't really belong to a particular oxygen, they're just kind of all stuck in there in this lattice form. So the magnesiums are positive, the oxygens are negative, so they're just attracting each other, but you still need it to be neutral. Well, because these are both 2 and 2, they cancel each other out. All right, so you want to look for your lowest whole number ratio. So I would write that as MgO, because I have 2 of each. The same thing for aluminum nitride. Aluminum is a 3+ charge, and nitrogen is a 3- charge, so they should cancel each other out. So I would just write that as Aln. All right, so the subscripts in ionic substances you want to always reduce to the lowest whole number ratio. This is sometimes referred to as an empirical formula, and we'll talk more about empirical formulas in another unit. And we call these compounds formula units. We don't call them molecules. Molecules, if you remember, are for covalent compounds. Okay, so we call these things, the ionic compounds, formula units. All right, go ahead and pause the video, see if you can do these. All right, rubidium is in column 1, so it's a 1+ charge. Iodine is halogen, so it's 1-, so that's Rbi. We already know that rubidium is a 1+. Phosphide is a 3-, so this becomes Rb3p. Radium, if we look up radium, radium's at the bottom of the alkaline earth metals column, so that's a 2 plus charge. Iodine is a halogen, so it's a 1 minus, so this becomes RaI2. And we have a 2 plus and a 2 minus. Remember, the 2's cancel each other out, so we end up with RaS. Ra2S is not correct. It has to be Ra2S2 is incorrect. It has to be RaS. All right, try some more. Pause the video, give it a shot. All right. CaBr, calcium, is 2 plus. Bromine is 1 minus. So I have to take the 2, put it after the bromine, so it's CaBr2. Calcium is 2 plus. Oxygen is 2 minus. They cancel each other out, so that's CaO. Calcium is 2 plus. Nitrogen is 3 minus. So my numbers cross. So I get Ca3N2. And how about aluminum chloride? Aluminum is a 3 plus charge. Chlorine's a 1 minus charge. So it's AlCl3. Okay, try some more. Pause the video. Okay, I told you this is rote, guys. You've got to do it a lot just so that you get comfortable with it. And the more you do it, the more familiar you are, and the quicker you can do this. And by the way, speed's important. Remember, your tests are timed. Okay, so aluminum oxide, you cross the numbers and you get Al2O3. Aluminum phosphide is 3 plus, 3 minus. So it's ALP because the 3's cancel each other out. Magnesium sulfide, 2 plus, 2 minus. So this is MgS because they cancel each other out. And potassium is 1 plus. Nitrogen is 3 minus. So this is K3N. All right, guys, so in summary, the ionic substances are always cations and anions. And that means they are positive and they are negative. And they hold themselves together because they are positive and negatively charged, and they attract each opposites attract. We always need to identify ionic substances versus covalent substances, and we'll talk about that in the future. Cations retain their name. That's the positive, the metal. And the anions end in IDE. That's the thing that's on the right-hand side of the periodic table. When they're on the periodic table, they end in IDE. You need to be able to convert compounds to names and names to compounds. We've done that a lot. But you really need to do the worksheet and do every problem and make sure that you get them all right. Okay? Questions? I'll see you in class. Have a good day. Bye-bye.